Each digit in binary numbers is called a bit. So the only bits that are in binary code are ones and zeros. After binary digit. Uh, 101 has three bits, as can see. 1101 has 4, as can see, and it goes on from there. There's a special count of bits that is used in computer programming a lot, and it has its own term. This count of bits is 8 bits, and that's called a byte. For example, 11111111, that would be categorized as a byte. Next, we're going to be learning how computers store numbers and other digital information. The place where computers put numbers for later usage is called memory. Memory is like a huge shelf with drawers stacked up on top of each other, such as the one I'm drawing. Each drawer has an address, and they go from down up. And each drawer contains 8 bits or 1 byte of information. If you need to store more information than a byte, you can use the next few drawers. For example, you can use 1 and 2 to store 2 bytes. And 4 and 5 to store 2 bytes. That's how you store things in a computer. When a computer is given different types of information, it takes different amounts of space in memory. For example, some types include char, int, and float. These are 2 popular ones, some main ones. Char stands for character. Int stands for integer, which are just basic numbers, simple numbers. And float stands for basic numbers with decimal points. So, I've pre-made a storage drawer, and as you can see, there are different spaces for bytes here. Let's go 1, 2, 3, 4, 5, 6, 7, and 8, and 0. So, when we're fitting different types of information, as I've said before, it takes different amounts of space. So they have different amounts of bytes. So for character, it takes up only 1 byte. For int, it takes up 4 bytes. And for float, it takes up 4 bytes once again. So in here, if we wanted to store in some of these, if we wanted to store an int, it would take up 4 spaces, an int. So this would be the space for a number like 5.